All right, guys, I'm going to do B and C in this second video. So if you want to see A, you'll have to do the first video, which you should have watched already anyway, because that's the one that I'm checking for homework. All right, I'm going to zoom in this time, because apparently the other one was hard to see. So I've got this function. It's a cubic function. All I know is I got to find the roots. So I'm going to apply the rational root theorem here, because my possible roots are going to be plus or minus all the factors of the numerator. Well, my numerator is 2, so either positive or negative 1 divided by plus or minus all the factors of our lead coefficient, which is also 2. So what this is telling me is that one of my roots could be any combination of these. Maybe I use positive 2 divided by negative 2. Maybe I use positive 1 divided by positive 2. Maybe I use negative 1 divided by negative 2, or whatever it is, right? So I've got all these different choices to negative 2, right? All my different options. These are my choices. So what I do is I use the Desmos Calculator to figure out which of these works. So let me bring that up. All right, so here's my Desmos Calculator. Now I could do f of and figure out what these are, right? So I could just start doing f of and try all my numbers. Eventually, when I try a bunch of numbers, I can try the number 2, and I'll see that that equals 0. So 2 is one of my roots. So let me get rid of this. Now we know that 2 is a root because we checked it on the Desmos Calculator, or you would be able to check it on your graphing calculator during a quiz or a test. And now we're going to factor that out. So I'm going to use synthetic division because that's the method that I prefer. It's really, really quick. If you want to use long division, you can. So I'm going to use a 2. I know that my remainder is going to end up being 0, which is good because now I have a quadratic. And now I can use either the quadratic formula or the completing the square method. So I'm going to show the work here for the completing the square method. All right, I'm showing this one because it is a particularly tricky completing the square, and I'm going to use fractions. So remember that if my lead coefficient is not 1, I have to divide everything by 1. So I'm going to have x squared plus 1/2 x equals 1/2. Now I have to add b over 2 squared to both sides. Well, 1/2 divided by 2 is the same thing as 1/2 times 1/2. So that's 1/4. 1/4 squared is 1/16. So I'm going to add 1/16 to both sides of my equation. And I know that that looks really bad, but remember that we can guarantee now that this double bubbles, because this is always going to be x plus or minus, depending on this symbol right here, whatever half of b is. And on this side, I can't add these because they don't have a common denominator. So I'm going to turn this into 8/16 because that's equivalent to 1/2, and now I can add that side. On the left-hand side, I'm going to turn this into x plus 1/4 squared, which equals 9/16. All right, so now I have to take the square root of both sides. And this square root over here is going to be pretty nice. I'm going to have x plus 1/4. And over here, the square root of 9 is 3. Square root of 16 is 4. But remember, when you take the square root, you could have a positive or negative version of that. So now I just have to subtract 1/4 from both sides. So I have negative 1/4 plus or minus 3/4. So remember, it's asking for all the roots. So I know that one of my roots is 2. If I do negative 1/4 plus 3/4, that's going to give me 2/4 or 1/2. And if I do negative 1/4 minus 3/4, that's going to give me negative 4/4 or negative 1. And those are my 3 roots. All right, last one. I'll try to make this one as short as possible, but it's got some multiple steps to it. So f of x is a 4th degree polynomial. So I'm still going to start off, I got to factor some things out. So I'm going to start off by setting up my rational root theorem. So I got a lot of possibilities here. I could have 6, I could have -3, I could have 2, right? There are a lot of choices. I think I got 8 possible choices here. So I'm going to try them. There's a very easy way to do this on your graphing calculator, but you've got Desmos at home, so you can do this pretty easily as well. Just determine one of the roots. Well, I've determined that f of 3 is 0. So I'm going to be able to factor that out. I choose to use synthetic division because it's pretty quick. All right. But now, when I'm done with this, I have -x cubed plus 3x squared minus x minus 2. Still can't use the quadratic formula or completing the square on that. So I'm going to have to do it again. I'll set up my rational root theorem. Could have 2 or 1 as my numerator, plus or minus 1 as my denominator. A lot of different choices, but one of them here would be a positive 2. And I've determined that if I use positive 2, that is one of my roots. So I'll set up -1, 3, -1, -2, based on my new polynomial, right? I'm using this now, and if it's a factor of that, then it's a factor of f of x. So I'll put a 2 here, use my synthetic division. All right, so now I've got -x squared plus x plus 1. That's a quadratic. And now I can use the quadratic formula or completing the square on it. I'll use the quadratic formula this time just to be different. All right, sing your song, set it up. Your A is a -1, your B is a 1, and your C is a 1. So I'm going to simplify this as best as I can. I got a -1 plus or minus the square root of 1 plus 4 over -2. So that's going to be the same as -1 plus or minus the square root of 5. That can't be simplified. So what are my roots? Well, I know that I have a 3. I know that I have a 2 from earlier. I've also got a -1 plus the square root of 5 over -2. And I've got a -1 minus the square root of 5 over -2. And that's all 4 of my roots. So you use the rational root theorem to help you find the initial ones. And then once it's a quadratic, you could double bubble it if it turns out that you can, or you can just apply the quadratic formula or completing the square. All right, guys, so good luck with this. It's just a quick little lesson. It's the last new thing before your unit test, and then you'll be practicing all of it on Monday. Have a nice weekend.